So once again, welcome to Get Started with Essential Chemistry. I am Barbara Puglisi. I'm with PASCO Scientific in the Curriculum and Professional Development Department. And my colleague Heidi is the manager of that department, and she'll be assisting me today. So please use the Q&A to ask questions to Heidi, and she'll get to you as soon as she can. Now, here's what we're going over today. We will be looking over the Essential Chemistry Curriculum program. What's in it? What's it all about? How do you use it? So within that program, you'll see how the student textbook is different from a regular, handheld textbook. We'll look at the interactive features of the digital book. We'll look at the teacher book, which is available digitally. We will look at the components of a lesson. Also, we'll look at the types of labs that are available in the curriculum and what makes our curriculum unique from other programs. We'll look at the test bank, which we call the Infinite Test Bank, and I'll explain what that means when we get to it. And finally, another resource that is pretty helpful for teachers, PASCO Academy. That'll be the last thing that we cover. And as we go along, I'll throw in some hands-on activities. For example, let's begin with this one, evaporative cooling. So here's a quick preview of what the Essential Chemistry curriculum is all about. Let's say that you're a classroom chemistry teacher and you're beginning the second semester with phase changes and just kind of reiterating and reviewing the concepts learned in the previous semester, such as the energy it takes to make a phase change, chemical and physical changes, chemical bonding, polarity, and this one activity can combine all of those concepts into one. So let's look at the ebook. Let's say you assign a couple pages of reading, just a couple in the beginning of chapter 11, which is right about in the middle of the year. So students are reading in the ebook. And the first thing they see, they get an introduction to some kind of event that they've experienced in their everyday lives. There's a visual representation of the phenomena that's going to be studied in this unit, along with some experiential phenomena. They know they know what it's like when a solid turns to a liquid to a gas with their experience with water. And then there's this also this representation of the symbolic, the numeric, mathematical quantities that will be studied in this chapter. So as they're reading along here early on, they see these nice representations of the concepts, but also they'll come across every now and then these interactive simulations. And in the digital book, when they click it, it opens this viewer of an activity that has directions. So if students aren't sure what to do, they can just go in there and start clicking and learn something, or they can read the directions. And this one happens to be about boiling point polar and nonpolar. So they can start the simulation and play with the controls, increase and decrease the temperature, and see what the difference is when you heat up and cool down a polar substance versus a nonpolar substance, and make some observations. And what does it take to get that phase change to happen based on the polarity? So they play around with that. Let's say that's how you begin your second semester. Then after they just do a couple pages of reading and they get their chance to do some exploration on their own, then they do the hands-on lab that goes along with this unit. So this might be where you're familiar with PASCO. You might know us for our sensors and software. The unique thing about the Essential Chemistry curriculum is the idea that we take the experiential learning, the experiential knowledge that students already have, the macroscopic level knowledge, and we integrate it really well with the submicroscopic level, the particle representations, as well as the symbolic representations with mathematics, writing chemical formulas and equations, and data collection. So I'm going to switch my camera so you can see my experiment set up here. Okay, so here we have a temperature sensor that's already connected to the software, which I'll go over this later in the session. So here's just an introduction. This activity says for students to set the temperature sensor in water for about 1 minute to let it get to equilibrium with room temperature. And I can look at the preview and I can see it's 23.6 degrees Celsius, so it's not changing. That's a preview live data right there. And then it says to remove the sensor and start collecting data. So let's start and then remove it so we get the background temperature. And I'm going to switch cameras so you can see, hopefully, there we go, that there's a little drop of water stuck to the bottom of that temperature sensor. And you can barely see it on the edge there. It's the shiny part. And in fact, before I even switched the camera, an extra drop fell, but there is a drop that remains. Let me see if I can get any closer and try and resume it. That didn't help. Let me try again. Get it more zoomed. Apologies for the focus. There we go. That's good. Okay. So we can see that the drop of water is still there at the end of the probe. And if you're watching the data go at the same time, it's continuing to cool down. And this file is pre-set up. It's already set up to turn itself off at 60 seconds. It just stopped on its own. I didn't hit the stop button in the software. You might have noticed that my mouse was in the middle of the screen the whole time. So the file's already set up for students to collect data on something that they might already recognize. Oh, I'm seeing water evaporate, and wow, that temperature dropped while that was happening. They might have made that connection already. One thing is for sure, they can tell you just by looking at the graph, temperature is dropping. Even though it used to be at 23.6, it's getting cooler. That's not something I'd expect if this was dry. And that's something they could test if they wanted to by doing a run with a dry sensor. Then the lab tells them, let the sensor come back to equilibrium, dry it off. And then now I'm going to show you my setup again. Now put it in isopropyl alcohol. So this is 91% isopropyl alcohol, and I'm going to give it a second to come to equilibrium. And ideally you would give it a minute, but for time's sake, I'm going to start it a little bit early. And I'm going to do the same thing. I'm going to start and then remove it and let it run for 1 minute and then examine in detail what happens. Okay, so I took the sensor out and now I'm going to switch to my zoomed in camera. Okay, I can see that there is a little drop there, but oh, look at that data. I can see that it is much more quickly decreasing. And since it's the middle of the year, maybe your students are using words like slope. The slope is much faster, or the change in rate is much faster. Or it's definitely dropping faster than water. And if you're looking at the zoomed in picture of the stainless steel probe, you can see that there is a drop there, but it's smaller. But the data is flattening out already. It seems to have reached its minimum. And ever slow little bit, you can tell that the drop is getting a little bit smaller as opposed to the water, which stayed there much longer. So again, you're going to see that I'm going to move my mouse over here so you can see by 60. It's going to stop on its own. It's preset to stop after 60 seconds. And then students would do the same thing with acetone. And then they can compare water's profile versus isopropyl alcohol's profile with acetone, which I'm going to skip because just to save some time here. Then they would build a molecule of water, a molecule of isopropyl alcohol, and a molecule of acetone. And they would use the molecular model set that comes with the basic kit, and they would look at the differences, and they would look for patterns, and they would see, oh, I see the red and white in all three. I see oxygen and hydrogen. And then they can learn about, or if they already know about hydrogen bonding and particle attractions, they can recognize the more opportunity there are for hydrogen bonds, the slower the evaporation rate is. Water was slow. I've got a few areas where we can get hydrogen bonding occurring. Isopropyl alcohol does have an area where hydrogen bonds can form, but not as many opportunities as water. So it evaporates more easily. That's probably related to the hydrogen bonding. What about acetone? There are no oxygen hydrogen bonds on this molecule. I wonder what its profile will look like. So that is just a quick a peek into what we're going to see with this curriculum. Okay, so now what is essential chemistry? It's curriculum. So one of the components of this program. So here's an overview of what's all there. A printed textbook, optional, with the digital textbook. And another option is the print lab manual. Go ahead and switch that out, Heidi. I'm done with that. Thank you. The digital teacher edition Comes with a lab manual as well as a student edition. They both come with a lab manual. The teacher edition is digital only and an optional print version of the lab manual. It also You can also get equipment with this curriculum. So you could either choose between the starter pack or the extension lab kit, and the activities I'm doing today are coming out of that starter kit. So that molecule set that I just used and the temperature sensor that I just used, those are both in that starter set. Then what else is included is the software that I showed you that you need to use with the sensors. On top of that, there is a test bank that comes with the curriculum, and it's called Infinite because the quantitative questions change values. So you can make 2 or 3 different versions of a test, and each time a question comes up, let's say it's about calculating the amount of grams from a reaction, all 3 different versions will have different values for that question, not only in the question itself, but also in the answer choices. That would be reasonable choices depending on if you made a mistake or if you did it correctly. So it makes it a little bit nicer for the teacher to have better test security that way. And on top of that, there's this piece called the PASCO Chemistry Academy, where we walk through some of the labs in essential chemistry. And I'll go over that in detail towards the end of our time together. So here's how the student book is organized. There are 8 units, the traditional topics that you would see in most chemistry books. And then within those 8 units, there's a total of 24 chapters. Every chapter has between 2 and 4 sections for a total of over 800 pages in this book. There's a lot of stuff in here. So now let's look at the difference between what you might see in the print book versus the ebook. I'm going to switch my camera to the print book. And so the print book is like any book you might expect to see. It's going to start with a topic at the top. So this is the beginning of section 8.3. There's one topic per page, so I know that this page is going to be about limiting reactants. And then there's also topics for paragraphs, so it's outlined nicely to help students see the big picture and put the ideas together in sequence. And then if there is a simulation like we just looked at with the polar nonpolar melting point, there'll be a cue in the print book. Here's a icon that looks just like the one that's in the ebook that I clicked earlier. The other nice thing is the textbook pages are identical to the digital pages. So if I'm here on page 239 in this print book, that's 239. If I go to 239 in the ebook, let me switch over to 239. It's the same. But it's not the same really. I mean, it has the same words on the page, but there's more than just the words on the page in this digital book. Let's look at how did I get to this book? Let me go back to the beginning here. Well, when you go to education.pasco.com, you're met with this screen that you see down here. I've already logged in to my book, so I just wanted to show you what it would look like if you were to go there right now. If you went to education.pasco.com, you'd see enter access code for essential chemistry. There's also physics curriculum. So when your school district or school site adopts essential chemistry, you'll be sent codes for students. It's only one code for all the students, and that eliminates a lot of hassle with forgotten codes, switching devices. I lost my device. Can I use my phone? Yes, you can use your phone. Can I use my iPad? Yeah, you can use your iPad. What's the code? I forgot it. That's okay. Everybody has the same code. So everybody in the same school district, in fact, for adoption, has all of the same code. And the way that that works is when the license is purchased, you purchase a certain number of seats for simultaneous users. So as long as you've got the same number of students every year, you're good. And it's just the same code the whole time. So I've seen any number of license years from between 1 and 7 and everything in between. So when you go to education.pasco.com and you've entered a code, let me get to my student screen. There it is. Let me bring it over really quick. There it is. Okay. So when you go to education.pasco.com and you've logged in as a student, you have the option to either open the book or sign out. So I'm going to open the book, and we're going to dive into what's called the home page here. The first thing you see, we're going to call this the home page. So students probably are not going to care about standards, so I'll go over that when we talk about the teacher edition. Here is the textbook. This is a link to the lab book. The lab book is built in, and every chapter is side by side. They each have multiple labs, both traditional and sensor based. So it's not like all the labs are sensor based. There's over 70 labs, and over half of them, or just about half of them, are sensor based. But there's also those traditional labs, so that you can work your way towards using more technology in your classroom effectively, while relying still on doing some traditional labs. And along the way, learning techniques like setting up a graph and how to do calculations. So those lab skills and math application skills are still there. But in addition to that, you've got the quick, already built graphs in SPARKvue that are modeling those correct graphing techniques, like take up the whole page with your data, use the um, label on the X and Y axis with appropriate units, and make sure that your numbers are an appropriate range on your X and Y axis, and put a title on your graph, etc. The problems, we'll go through these individual icons as we get to the textbook. Of course, an appendix, just like any other book has, and then the help. Okay, so if a student gets lost at any time, or if maybe this is what you do the first time you have your students use this book, tell them go to the help and watch these videos on how to navigate the book. I'm going to go over a lot of what's on that video right now, but students can always just watch the video. There's also the first time they use SPARKvue software. What we did is we made this helpful video of, we went through every single lab, and we looked at every single skill that students would need for all the analysis and all of the things that they're asked to do in all of the sensor-based labs, and we made a video that covers it all. So that help is right at their fingertips for not only the book, but also the software that goes with the sensor-based labs. Okay, so, well, I didn't mean to do that, but let me go back a couple clicks there, and now I'm back at home. Okay, so what is the difference between the home page and the book? So you got a little peek of, I accidentally clicked a link and it went to the book. So the left side here, that's the home page. The right side here's inside the book, and it looks just like the print book, like I said before. But they work a little bit differently when you're on the home page. And let's say you click the icon that says interactives on the home page, you'll see a list of all the interactive simulations in the entire textbook listed by chapter and page number, and you can click them, they're linked. But if you're in a chapter already, let's say you went to chapter 8, the stoichiometry chapter, and you click that interactive buttons, you will still see a list of all the interactive simulations, but only in the current chapter. So if you're in chapter 10, you'd get a different list than what you see here. I am going to go over, what are these simulations? What do they look like? You already saw an example of one of them, but there's many different kinds that you'll see inside the ebook. So how do you get between the homepage, the ebook, the lab manual? Well, the navigation's pretty simple, so everything starts on the homepage. You can go back and forth between the book. So when you open the book, if you hit the home button, it'll take you right back to the homepage. If you want to do the lab book from the homepage, you can do that. To get back to the homepage, you can hit the home button, but you can also switch between the the textbook and the lab book just by hitting the icon that you're aiming for. So let's go and look at that now. So here I am in the student book. I want to go to chapter 8. So I'm going to click book. That'll bring up the table of contents, and I can go to chapter 8, stoichiometry. Now that I'm in chapter 8, everything that I click here at the top will take me to content for this chapter. To navigate left and right, I can either click the buttons at the top, left and right buttons. I can do the same at the bottom, left and right. I can use the arrows on my keyboard, left and right arrows. If I have a touchscreen, I can swipe. So I have all kinds of options for navigation. So here I am in the beginning of chapter 8, and every chapter begins with a story. So the story of stoichiometry in your everyday life. And you'll notice these read aloud from the text icons. The student edition has an option to read aloud. Listen.
If you poured some baking soda into a cup full of vinegar.
So students can have the book read aloud to them, but also on top of that, this book is HTML format, so it runs in a browser. So when you're on the first time you log in and you put in the code, that code is remembered every time you go back to education.pasco.com. There's no putting the key in every time. It just remembers it. It's stored as a cookie. So if you went to a different device, yeah, you'd have to put the key in there, but it'll remember it every time. And that goes for your computers, Mac and Windows. It goes for tablets. It goes for your iPhone, Android phone. All of your devices work with this. So you could also turn on translation, doing a translation tool if you have one of those in your browser as an extension, and it'll read it in whatever language you have that set to. So the book itself has all of these icons are going to be in English, except when you get to a vocab term. So here we are, the second page of every chapter. After the introductory story has a preview of what you'll see in that chapter with links to each page in the chapter. Remember I said one topic per page. So if a student gets through a chapter and they're reviewing and they think, you know what, I need more practice on mole ratios. I don't think I really got that. They can always come back to this page and quickly find mole ratios, click the link and get to that topic on that page that they're looking for. Then at the bottom in this introductory page, you'll see vocabulary terms. And when you hover over, it gives you the definition. If you click, it'll freeze. And it also has the option to read aloud
Stoichiometry, the study of the
in English, but also the vocabulary are translated to Spanish as well.
Estequiometría, el estudio de las cantidades.
So there's that. This is all the vocabulary in the chapter. Then when you get into a chapter page, the first time a word is introduced, it's bolded, and there's that vocabulary box again. There's that bubble where you can, again, read it aloud or read it in Spanish or English. Let's talk about some of the things at the top, the icons at the top of the page before I talk a little bit more about the digital enhancements to the book here. So navigating the book, I mentioned you can use left and right arrows, but you can also, if you click on the book icon, you can go to a different section in any chapter. You just twirl open the menu and navigate that way. That's another way to navigate. Then if you wanted to switch to the lab book, you could click this button, but I'm not going to do that just yet. You can jump to any page number quickly to, like teacher says, go to page 144. You just jump to page 144 by typing it in here. The search is a keyword search. So if I look at molecule, it starts narrowing down. Oops, you have to spell it right. So here are my choices for molecule. And then I can click and it links directly to the page that it's first introduced. Okay, and problems. If I were to click the problems button here on chapter 8, it takes me to the end of chapter problems in chapter 8. If I were to hit that button on the home page, remember home, looks like that. So if I hit the problems on the home page, I'll get all the problems in all of the chapters in the whole book. But again, once I'm in the book and I'm in a chapter, I get just the chapter set of problems. STEM. This is science, technology, engineering, mathematics readings, just short little paragraphs that might be of high interest to students depending on what they're interested in. So what if they're interested in green chemistry? You can read about it here in this chapter. Click it. There's the paragraph highlighted in yellow that has to do with green chemistry. So this helps engage student interest by having that option. Then there's the interactives. So like I mentioned before, if I click interactives, I'll see all the options in chapter 8 here. And there are a bunch of different things that you see here. You see 3 main types of interactives. You see this chemical equation, and they're balanced. So there's the balanced chemical equations. Then there's something that says simulation, getting ratios right, simulation. You'll see another one here that says limiting reactant simulation. When you see the word simulation, it's going to be like that first one I showed you with the molecules that are polar and nonpolar, something that students can click and discover, discovery learning, or if there's an assignment written around it, there might be an assignment. So far you've got equations, you've got simulations, and the third thing is the molecules. And I'll go over what the equation and molecules look like in a moment. I've already gone over one of the simulations. Before I go on further, I'm going to pause and see, Heidi, is there any questions that we should address to the group?
Yes, we actually got a question in from Marie who's asking, do we have the final answers available to students or teachers or both when working through these questions?
Which questions? Let me think about what I was the problems?
Correct.
Yeah, okay. So if you're working through the problems, here's the student view. Can you mute your mic, please? Thank you. So on the student view, these chapter 8 review questions, the students don't have answers to these. But if you've ever used essential chemistry, you'll see a lot of places there are answers. And that's because we believe in students learning on their own, formative learning. And I'll go over where they see answers and when they don't in just a moment. But the quick answer to your question, Marie, is that at the end of the chapter review, that's where in the book you're going to see consistently they're not going to have the answer there. it's a um, it is teacher side only, and I'll be showing you that when I show the teacher edition. Thanks for the question. Anything else, Heidi?
That's all we have for now.
Okay, thank you. Thanks. Keep those questions coming in, and Heidi will do her best to keep caught up with you. Okay, then elements. So if you hit the elements button, there's a periodic table. But wait, there's more. It's what you would expect on the periodic table. It's got the groups and periods. It's got the atomic mass, the name. We've got the F block out here, and also the color coding for the different families. There's more yet. Here are common polyatomic ions, constants. These are the kinds of things that you would see on a standardized exam as a sheet given to students. And these are actually a nice laminated set of this exact set of information is included in the equipment bundle. Now, the atomic orbitals, SPDF block on the periodic table, some formulas, ideal gas law, combined gas law. Again, you might see this on the AP advanced placement exam, or maybe some of these formulas are given on the for IB students. Unit conversions given here, and then some very common properties like what's the density of the first 52 elements only. We didn't put them all here, just up to 52. Okay, so that's what you'll find on elements. It's just like a reference that you normally, I don't know about you, but when I was in a classroom, students had this in their notebook at all times, all of this information. It was something they learned to reference regularly. Equations is a shortcut to a simulation that I'll go over in a moment. An appendix. Appendix is more than the appendix in the digital edition. It on top of the appendix, there's also the glossary, index, and standards. But if we click appendix, all the reference tables that you'd expect are here. For example, pH indicators and ranges and choices of indicators you might pick based on the pH of what you're working with. Okay, so that is a broad overview of what these links are, but we're going to go back and look at the interactive components and chapter. I'm going to walk through chapter, go back to 8.3 where I was a second ago. Okay, I'm going to go back to my book here. So here's a interactive simulation. If I click it, here's another one of those students' discoveries. A student just click through and discover something with some directions to them. And it says simulation, so that's a simulation. Here is some read aloud text. You'll notice, again, here's some really nice graphics. And what's nice about this, whether you're a student or a teacher, you can, again, because this is browser-based, if you right-click over the image, you can do save image as and use our images according to fair use. Because for educational purposes, go ahead and put these in your own PowerPoints. PowerPoints do come with the teacher edition, and I'll go over the resources for the teacher, but students might also be doing presentations where they could really use that graphic. All they have to do is either copy or save it, and they can put it in their presentation as long as it's according to the fair use guidelines. So that goes for all the pictures. Okay, let me go to the next page here. And let's see what's on here. Okay, well, here's something that says more. If you are in the print book, you're not going to see the more. I'm going to switch real quick to the print book. So this is page, that's this page. Okay. There is no speaker icon because you can't get the print book to read aloud, but there's also no more icon either. So you have to be in the digital book to know that this more button is even here. So what does it do when I press it? It gives me more. So what that means is here is a topic that is primary content that students must learn. But when they click the more button, there's something there that's either of high interest, something out in the real world. This happens to be an environmental connection to octane and gasoline and the environment. Sometimes it's a fun demonstration that they could do at their desk. It can be any number. It can be an animated GIF of some cool reaction. Just click them when you see them. They're fun. So it's like stuff we wanted to include. And by the way, when I say we, I'm one of the co-authors of Essential Chemistry, and all four of us, between the four authors, we have over 50 years experience in the chemistry classroom across 6 different states, and all of us got together and just really thought about what are the kinds of questions that students have? What do they struggle with? What are the things they're interested in? What do they want to know more about? How do we get all that content into this book? And that's why you see so much interactive digital content here, is because we're basing this on not only our own experience, but also we got some feedback and had teachers from all over the United States and Canada help us and collaborate in making this book. So moving on, then you'll start to see when you see worked problems or solved equations, they always have the correct amount of sig figs in the answer. They always show the chemical formula and the unit, and they show the pattern of crossing out. They show step by step what to do. They even show that your calculator might show this number, but your final answer is this over here because of sig figs. So that's a nice reinforcement you'll see in every chapter, as starting from chapter 2, where sig figs are introduced. So here's another example of a solved problem. A solved problem is a very structured version of a question that gets students ready to start answering these on their own without answers given. It helps them organize the information. It helps them create a pattern of thinking when they answer these questions. What are you being asked for? What are the things that you're given with units and chemical formulas? What are the relationships that are important here? How do I solve it? What are the steps? And when I finally get to the very end, that's when I round for sig figs and the final answer in a complete sentence. Okay, so moving along here, I'm just going to make my way through, and oh, look at this gray paragraph. So this gray test our knowledge paragraph will not be in the print book. It's digital content only. It's there for students to take a moment. When they see that, it's like a red flag. It's a gray flag, but really, it's really, hey, stop. Hold on. Before you go on to the next page, stop for a second and see if you can answer this question. Do you get it? I don't know. Let's see if we got it right. Hit show solution. There's the answer with step by step again and an explanation. Do I understand it well enough to move on to the next page? Yes, I do. Great. I'm going to move on. No, I don't. I need to stop and ask the teacher for help. So again, this helps students gauge their own understanding on their own, and helps you, the teacher, decide you might even want to do this as a class activity, or before you leave today, get through this. This is the last thing you do today, and help students know when they are lost, or know when they are confident and they can move on. So here we are at the end of a section. This is the end of section 3 in chapter 8. So we have a review of what was in that section, and we have the summary of the vocab terms that were in that section. Then, as Marie had noted, she was asking, do you have questions where there's no answers given? Here's some more examples of questions that do have answers given. Now, most textbooks, at the end of the section review, they'll not give the answer to the students. Our book gives the solution, because we believe these are formative assessments. This is where it's okay to fail. This is where you find out where you're failing and where you get help. So when you hit the show solution button, it gives the answer. If there's a calculation, it shows step by step. And that goes for all the questions. Okay, so, but not to worry, there's more places where there are questions with no answers. I already showed you the end of chapter, which we're going to get to in a moment. Here we are at the end of chapter 8, that every chapter ends with another story that weaves in the concepts and the not only cross-cutting concepts and the content, but also sometimes careers. At the end of a chapter, you'll see readings like this: green chemistry and engineering. And then finally, we're at the chapter review. So here we are at the chapter review. Again, these problems do not have answers given. There's little cues here to tell you the difficulty. Vocabularies, we always begin with vocab. Notice, because vocabulary is the easiest thing you can do, recall, there is no symbol on each question. It's just questions. But then when you get to the conceptual questions, you start seeing these chili peppers. So it's like, how spicy is this question? We've got 4 levels, okay, for like depth of knowledge. So we've got no spice, no peppers. So those are the easy ones, level 1 or 0, if you will. 1 chili pepper, 2 chili peppers, and the hardest one's 3 chili peppers. So it helps you gauge when you're assigning questions to students. Keep an eye on the number of chili peppers total that they're getting that night, or spread it out a little bit to make it more doable. but we give plenty of practice problems, not only conceptual, but also quantitative, and they're organized by section and type. So, okay, and again, those answers will be given in the teacher edition, which I'll get to in a moment. I'm going to pause here and see if there's any questions I should address, Heidi, to the group.
No questions as of right now.
Thank you. Great. Okay, moving forward then. I'm going to go back to those interactives I told you I would show you. So let me look at the slide and make sure I covered all the digital enhancements I intended to. Yeah, so a review of the digital enhancements. You can click on a vocabulary word the first time it's introduced. You can have it read aloud to you in English or Spanish. You can hit a more button to get more content that might be of high interest to students or fun demonstrations and so on. You've got the tester knowledge pieces when there's a critical time for students to really check their understanding and see if they're ready to go on with the answers given in the student edition. Then there's the interactive simulations. There, you've already seen the kind of simulations where students can push buttons and play. And then there's the kind that you haven't seen yet, the molecules and the equations, which I'll go over in a minute. You saw that the end of the section has these questions. I'm going to show you this thing called Take a Quiz in a moment. And then you saw that there are solved problems with sometimes something called the equation builder, which I'm also going to show you just now. So let me move over to back into the ebook. And we're going to go back to section 8.3. So I'm going to navigate with the book navigation here and go back to section 3 in chapter 8. Remember this section? Here's a quick way to get to the end of this section. If I know I need to get to the end of section 3, I can go to the component after it, which is connections, and then just go back a page. And now I'm in the end of that section. So at the very bottom here, we've got this link that says, let me zoom in a little bit. Take a quiz down here. It's an orange button and it's linked. Okay, let me go back to 100%. If I click that button, this is a quiz that students can get to gauge their knowledge, and it's something you can give as an assignment. And it's different for every student. So how does that work? Well, first of all, I'm going to keep hitting new so you can see what happens when I hit new. Every time I hit a new quiz, I get a new set of questions that are shuffled. Sometimes the same question appears twice, sometimes not. But something special about the numeric questions is if it's quantitative, like this question, it says you're given 24.4 grams of ammonium chloride and 7.56 grams of sodium hydroxide. Well, I'm going to look for that question again the next time I hit new. Remember, 24.4 grams of ammonium chloride. Okay, let's remember that. Let me hit new till I see it come up again. There it is. Look, 24.9 grams of ammonium chloride. That number changed. And let me hit it again. You get the idea. When it comes up again, you'll see that the number is different. There's 21.7 now. So this question is about limiting reactants. So that could change the answer depending on the amounts given in the question. Now that one is not a totally numeric question. What about ones where you solve a calculation? For example, this question 4 with the chlorine and potassium bromide. We've got 29.59 grams of chlorine. Let's look for that one again. Or is it? Come back. See how good it is at mixing it up for everybody? Come back. Okay. There it is. Now it's 18.01 grams of chlorine, and the choices have also changed. And again, these are reasonable answers if you did it right or wrong. One right answer, many wrong answers based on if you flipped over your proportion or something. So that is one way to control, for students, not only for students to keep practicing with new content, but also to limit cheating and copying. Well, how do you do this as an assignment? Once students put answers in, I'm just going to put random answers. Let's see how good I do. They put in their answers, they hit score. I got every single one wrong. There's a red X on every single one. If I got any of them right, it would give me a green check. But after I scored it on the ones that I got wrong, it gives me a hint. So if I want to try it again, I can. I can also go straight to the show solution button, and it highlights the correct answer, and it also shows the solution. So keep in mind this is a thing that's out there for every time a student gets one of these quizzes. But what you can do is have students keep taking the quiz and don't turn it in until they have a score of 100%. And once they have a score of 100%, they hit the print button and they can now save it as a PDF and turn it into you digitally, or they can print it to their regular printer. And that's how you assign this as homework. Oh, by the way, I forgot to show you that there was a name box up here so they could put in their name. And it's entered onto the quiz. There's my name right there. There. Okay. So that is a take a quiz feature, and now I can show you the other interactives. So let's look at in chapter 8. Again, 3 kinds. We've got equations, we've got simulations, and molecules. Let's look at the molecule next. Here's propane. So I could get it from this list, but I want to show you why that list is in that order. Let me find one here. Okay, here we are on the combustion of octane page. Here is some content about octane. Here's an interactive simulation, and when I hover over it, it says octane. So when I see a molecule name, it'll bring up this simulation called Molecule Viewer. And it's going to bring up octane. It's in context of what's on the page there. But remember, I could have got to it just by going to the interactives menu. So here I am with octane. That's nice. I've got octane. See, the carbons and hydrogens all spread out according to Vesper. I can grab my mouse and spin the molecule in 360 degrees. I can also scale it. I can zoom in or out with my mouse wheel or 2-finger pinch. I can change it from the ball and stick style to my favorite space fill, because students need at some point to stop thinking about molecules as balls and sticks. They need to think about the regions of charge in 3-dimensional space based on the atomic size and electron activity and all the things they've learned about so far. So this also can zoom in and out. And this octane, I expect that to be nonpolar. So when I turn on the charge surface, I shouldn't really see any sides that are overly red or overly blue. I should see lots of even distribution of red and blue, and even some gray areas. Red being positive, blue being negative, and gray being no charge. Now let's take a look at another more fun molecule. So as soon as I bring up this molecule builder, I don't have to stick with octane. I can go to the drop down and pick something else. Let's look at methanol. Okay, so let me zoom out so you can see the methanol. There's the methanol. There's that region. Oh, look at that. We've got, let me go out a little bit. I'm going to go to ball and stick so you can see it better. I've got a region of lots of positive and lots of negative. So this goes along with that activity you first saw with the temperature sensor. You might have students look at this simulation after they did that lab with the water and acetone and isopropyl alcohol and look at the molecules in here and look at the charge distribution and help them think through, why might the water molecules have evaporated more slowly than something with fewer areas of charge, greater charge disparity? So look at the bottom of the molecule here. It's more on the gray side. That's where it's not polar, but the top of the molecule definitely has polarity here with the red and blue region. So that's fun, and that comes up anytime you hover over one of these interactive simulations and you see a chemical name. Let me go back a page here. So hovering over this interactive simulation, but I see the word, it says limiting reactant simulation in the pop-up. So now I know that a simulation, a thing I can click and play with, will come up. On this one, again, it's got a chemical name, so that'll bring up the molecule viewer. And this solved problem, it says simulation here, so when I hover over, I get a reaction. If I click that, it brings up this equation builder. So when you see equations of simulation, this is another tool like the molecule viewer where it'll just open and you can use it how you need to use it. So what this is a tool to help teach and learn stoichiometry, but you don't wait till chapter 8, you don't wait till stoichiometry to start using this tool. Use it as soon as you start talking about chemical formulas and ions and crisscrossing and writing chemical formulas. That's where you can begin really to use this stoichiometry tool. Before I get more into this tool, any questions, Heidi?
No other questions have come in, but please feel free to ask.
Great, thanks. Would you mind swapping out the, thank you. Okay, so this equation builder, there you go, thanks. So right now, this is the equation that was actually on the iron oxide and aluminum replacement. That was on the page right here. That's the reaction that's relevant to the question. But I'm not stuck with that equation. I might talk about the mole ratio. This equation is already balanced and done for me. But if I want students to just learn from this, there's a button at the top that goes to the builder that starts with just a water coming together. So water molecule. You're not stuck with the water molecule. You can modify this to whatever you want. I'm going to make something that's going to use all of the tools here in the equation builder. Let me zoom out a little bit so you can see the whole there. Now you can see it all. Okay. So I'm on the button up here that says equation. I don't want to do making water. I want to do something different. So I can select a term. It's red when I select it. You can see that some options change as I go through. On the reactant side, I want to delete the hydrogen. I'm going to delete the oxygen. That's not what I want. I have no reactants, and that's fine. I can add more. I'm going to delete this product as well because I really don't want that product. I'm going to delete that term. Okay, so now let's build a reaction here. How about some potassium iodide? So I want potassium, that's number 19K. I have to select K and it's pink. The flag is pink when it's selected. Then I add the element. Iodine is not in periods 1 through 4. So I have to click to get to periods 1 through 7. And now I can pick 5 through 7 and add it. And when I crisscross, I should remember it's +1, -1, and I don't need any subscripts. Now, if I want to react it with something else, I have to add a second reactant. That puts a plus sign between the terms. How about lead nitrate? So lead, here's lead right here. It's atomic number 82. I selected, I'm going to add it. Nitrate, rather than build NO3 as an ion, I have to realize that's an ion, so I need to go to the compounds and ions button there. And I find nitrate. So when students are learning, I know one of the things they struggle with is when they have polyatomic ions and they're crisscrossing and writing formulas, they get a little confused about subscripts, about charges, about crisscrossing those charges, when to use parentheses, when to cancel, when to not cancel. All that's so confusing. This tool helps reinforce how to work with ions when making chemical formulas. So there's nitrate, and it says nitrate. If they're on the periodic table looking for nitrate, they're not going to find nitrate. They find nitrogen, but not nitrate. So they have to pick the thing that says nitrate, and that's only in the ions. So then they add that, and it goes right there after the lead. Now, if they accidentally did, let's say that they did nitrate first, oops, they forgot to put a add reactant. So let's delete that term, and we could start over. Go back to potassium iodide and build that. They forgot to add the reactant. Okay, so then let's say they accidentally do this. They accidentally put the nitrate first. Oops. Okay, I got to put lead in there. Here's lead. That's backwards. They have to delete that. So they could also have done remove element. For example, I'm going to put lead and oops, I did that thing where I put 3 together. I can just hit remove element. Whatever's selected is the thing that will get acted upon. So I had lead selected and it removed just lead. Okay, so let me make my lead nitrate. And it does not automatically do the crisscross for you. If you forget to do the crisscross, it'll never balance. And students will figure that out right away. But when I put the nitrate in, it keeps it together as a single unit NO3. So if I do my crisscross, I realize, oh, I got to put a subscript of 2 on the nitrate. So the only way it'll let you do that is by changing the subscript. So if I change the subscript, it automatically puts in the parentheses to isolate, say, yeah, there are 2 of these nitrate ions. And that helps students see how to crisscross, how to put, how to use parentheses, when to use parentheses, and even the hydroxide that's so confusing, it does that for hydroxide as well. Now we're ready for products. So lead to iodide, or rather lead iodide. So lead iodide, they do the crisscross, they get that. Let's add another product. And that'll be potassium nitrate. And you go back to period 1 to 4, potassium and my ion nitrate. Great, that's my reaction. Now I'm ready to balance it. So when I go to balance, I can visually see the equation is unbalanced. And if I look, it shows me, oh, iodine, I only have 1 in reactants and 2 in the products, and it's visualized here. So as you're adding coefficients, and again, balancing, it only lets you add coefficients. So again, reinforcing what they need to know to be successful in balancing equations. They select the side that needs more iodine. They would, if they recognize right away, I need more iodine. I don't want to put it on the right side. I don't want to put it in the products. I already have too much there. I have to go to the reactants and then find the term that has the iodine in it, change the coefficient on that. And now that also changes the potassium. So it helps them understand balancing. It helps them visualize it. It helps them see that changing the coefficient is the only thing they can do. And it also distributes across the entire reactant or product. And now it's balanced. It says in green balanced. And then it's equal on both sides. Do we have a question, Heidi?
Yeah, we sure do. When we're looking at this equation builder, will the move element button switch the ions in citation?
Okay. Can you move? Thank you. The move element button. I mean, the previous, okay, let me unbalance it. Let me go back here. Remove. Remove element will be, you pick it, it's red, it'll go away. So if I hit remove element, just the lead will go away. Okay, and if I want to put it back, I can just select it and add it, but it's gonna go in the wrong order. So now I have to pick the nitrate and remove it and then hit the nitrate. Did that answer the question, or was that did I misinterpret the question? The previous and next. Is the question about previous and next? Because the previous and next also, like, instead of having to select the term, you can also use the previous and next buttons. They just go in the left and right order.
We got a clarification, the move element on left.
Okay, this one. Yeah. Oh, you know what? I completely forgot that was there. Yes, yeah, it does. I forgot it was there. Shame on me. Okay, thanks for pointing that out. Okay, let me make sure this is still right because I moved a bunch of stuff. Yeah, sorry, I totally forgot about that. Okay, let's go back to balance. And you can see that the reaction is balanced. And now stoichiometry. And here's what the stoichiometry does. This is something that students really struggle with until the day it clicks and then life is good again. So it's that whole idea of proportions. The moles, the number of units of one reactant to another, to the number of product, that proportion idea, and ratios and the mole ratio. So this part of the tool helps them really understand how it works, what it is, how it doesn't change, no matter what you change. So where proportion here is 2 to 1 to 1 to 2 when the reactants and products are written in this order. So if I were to say, what if I don't have 2 moles? What if I have 0.5 moles, some random number, okay? What does that do to the proportions? Oh, it's still 2 to 1 to 1 to 2. It reduces to that same proportion, 2 to 1 to 1 to 2. That's what the mole, the coefficients are in a balanced equation. It's the proportion in moles or amounts of each item to the other. But you might have also noticed that it changed the grams on the bottom. Let me do that a different amount. So how about 99.9 moles? That's a lot of potassium iodide. Wow, look at all those grams. I still have my 2 to 1 to 1 to 2 ratio and the 4 moles, but if I had 99.9 moles of potassium iodide, that would be that many grams. How do I know when I have that many moles? Well, I have a formula mass here in gray, and the formula mass for this potassium iodide is 166.03 grams for every mole. So when I multiply these values, I get this value. That's how I figure out grams from the gram and the mole proportion calculated against the formula mass. So they see that the formula mass never changes because the proportions within the compounds don't change, but the mole amounts can change. And they're regularly asked to solve problems like this. So speaking of solving problems, you might be thinking, oh, they can totally cheat with this. I have yet to see a student who can cheat with this without having learned how stoichiometry works, because you really kind of have to know what you're doing to cheat with this. It's really more for learning with. And once you've learned with it, by all means cheat with it because now you know how it works, now you know how the proportions work, and now you know how to interpret this tool. You get it. You've earned it.
So Barbara, are the grams editable?
Yes, they are. So I can go in there and change this to point very small. Oops, I'm going to put 100, 0.003 grams. What if I have barely any potassium iodide? Yes, it changes. I have less than 1 mole, so it's not that there's 0 moles, but it just rounds. for sig figs. So it's but it's not going below the 0 amount for moles. Let me change it to 3 instead, so to give a better example. Still have my 2 to 1 to 1 to 2 moles. It just rounded that value that I made too small, so that's why it wasn't able to calculate the moles. Usually you work in higher quantities than that. So if you're a teacher, you might already see the value of cheating with this tool. Like you're writing a lab and you're like, I think I want to use my gas pressure sensor, and I think I have a volume of this many milliliters, so I need X number of milliliters of gas, and you can use this tool to help you write labs. I use it all the time to help me when I'm writing labs and I need to think of the quantities to just come in here and use this tool. It's nice way to cheat. Okay, I'm going to show the last button and then we're going to stop for questions again. Keep them coming. On the show me how, what this does is it shows the steps of solving using the proportions. They're always one step at a time with moles. So it really just kind of walks students from one quantity to the next in order. So it really just shows you, how do I get from 4.6 moles to the moles of lead nitrate? Well, it shows that step. Well, how do I get from moles of lead nitrate to lead iodide? It goes one step at a time, really. Actually, it's based, sorry, let me rephrase that. It's based on the given. The given in this case was 4.6 moles of potassium iodide. And then now when I go to the next line, it's switching to the given of lead nitrate. So the red thing in red is the given. The numbers that are being used for the calculation are colored, as you can see here. This too, you can change the quantities. So here I have 6 moles. This time my given is 6 moles, so it's red. My answer is 12, and it for this first term, and it's just going to walk me in order through all of the terms on how to calculate them. So it's like, how do I set up from A to B to C to D to E? Again, students can't cheat with this because it really does just move them step by step from one unit or quantity to the next. So if you see a bunch of single equations in a row or single calculations in a row, you know they cheated with it, and you expect them to use a one-line equation calculation when they do stoichiometry calculations. Okay, I'm going to stop and see if there's any questions. Anything?
Nothing yet. We're ready to move on.
Thanks. Okay, let's see. Go over this slide here. So we just walked through the equation builder, 4 steps. Build the equation, balance it, use the stoichiometry tools, see how the calculations work. We locked the molecule viewer. You saw that you can choose multiple styles. You can turn on the shading for charge distribution. You can zoom, scale, rotate, and choose a different molecule. Now we're ready to look at the teacher ebook. So everything we looked at so far was all student. What's on the teacher side? Okay, so how do you get to the teacher book? It's just like you saw with the student book. You go to the education.pasco.com. This time I'm in a different browser and I'm logged into the teacher book already. So now that I'm a teacher, I can open the book and I've got 2 more options here. I have a test bank and the academy. Students don't get that. So before I click on the teacher book, I want to show you some things that are here on this landing page, more relevant to the teacher than the student, because what you see here is there's a link to standards and correlations. And that's actually the same as in the ebook. I remember I made a comment about when you open the teacher ebook, you use a student ebook, you see the standards. Those same standards are here on this landing page. So let me just click it. So what it does is it brings up the list of standards. This defaults to next generation science standards, but if you're in the US, then you can pick your state. Let's say you're in Texas, pick your state. It will bring up the TEKS. And it's searchable too. So if I want to see what are the TEKS, how are the alignments working for the TEKS in something like trends, periodic trends. So it'll search for every time it sees trends, and it brings up all the alignments for the trends in the TEKS that are linked to the pages in the book that have that content. So if I go to, it tells me there's student content, student assessment, teacher side only assessment. So if I go to page 130 and click it, it highlights in yellow where that alignment starts. That's not the only place where you'll see the content for that standard. It's just where it starts. So it continues on beyond the beginning of the link. If it says sidebar, that means it's in the teacher edition. And this is the teacher edition. I just opened the teacher edition. That only worked because I was already logged in as a teacher. And it points me to the left side. That means there is an assignment here that has trends. Oh, look, there's electrons and trends. Also atomic radius. So there's our first view at the teacher book. But I'm going to quickly go back. I'm going to go back home. I'm going to go back to the, what's the wrong page? I'm going to go back to that teacher login page, which I'm going to have to bring back up. I'm going to hit my back button there to get back. There we are. Okay. These video guides are similar to the ones, they're the same ones I showed you on the student side, except in the teacher, and you have the using the teacher's edition video. There's the navigating the ebook. There's using SPARKvue software. These are the same videos that are in the student book, but using the teacher's edition is unique for teachers. Then here's where you get the software. So actually, if you have a mobile device like a Chromebook, tablet, iPhone, it's actually already in the web store. For Chromebooks, it's in the Chrome web store. It's already free. It's there. But SPARKvue for Windows computers and Mac computers are licensed. But here is the download for the licensed version of software right here. When you log into your teacher book, it's just scroll down the page and there's the installer. So you can install it on your devices at work, at home. Students, this is also on the student page. They can download if they have Windows computers or Macintosh, they can put it on whatever device they have. If they have the mobile device, again, they would just go to their app store to get the app on there, and it's free on their mobile device. So here's another link to the test bank and academy. So these two were shortcutted already at the top, and we'll get to them in a minute. Then there's the equipment kits. So there's 2 levels of equipment here. And I'm going to try and do at least one more demo. If I have time, I'll do 2 more with the equipment. Okay, so now let's get back into that teacher book. Let's see what's in my presentation here. Again, the license works just like the student one. You put in the code once, it's remembered in the browser, it's browser based. One code for all the teachers in the district. So it's easy to retrieve the code. And again, the specific numbers of teachers are licensed for whatever the license term is. I already mentioned this about saving images. You can use that. This works for animated GIFs too. So on page 285, and I didn't really show you an animated picture. So let's look at page 285. This is the teacher edition, but since it's book content, it'll be the same as the student edition. So on 285, if I hit the more paragraph here, and I hover over this image, it's an animated GIF and it's showing the reaction with sodium and water on a loop. But you could right click and save this image and put it in your PowerPoint presentation, or just have it on randomly. Students love seeing this stuff randomly. Okay, so let's talk about what's in a lesson and how the teacher book is structured. Let me get a view again of the teacher book. So let's go back to chapter 8, section 3, where we were before. So here's the teacher view. Now, there's that left side that wasn't there in the student book. Look at this yellow highlighting on the left side and at the bottom. This is what the teacher, how you can distinguish teacher from student edition is you've got yellow stuff and left side stuff to the left of the book content. The second page in the chapter is the same as the student page, but then once you get into section 8.1, here we are in the first section of chapter 8. Look at all these teaching resources. I'm in section 8.1. We've organized the lessons by section. So if you look into chapter 8, I have 1, 2, 3 sections. That means there are 3 lessons. And it's just for convenience. It's just how we organized it. 3 lessons in chapter 8. In chapter 7, I've got 2 lessons. In chapter 9, there are 3 lessons because I have 3 sections, section 1, 2, 3. So that's how the lessons are structured and organized. Starting every section, you've got a lesson plan that is not only a PDF, but is also editable. And in the lesson plan, you'll find things like the learning objectives, things students should already know, stuff to look out for, some assignments that are included in this section, and also some ideas for whole group discussion to engage student interest. Okay, and close that. There's a docx version, so you can edit it for your needs. There are PowerPoint slides, again, in editable and PDF formats for you to download and make whatever way you want for every section. Then there's student assignment section. So here in section 8.1, there is a lab. Go to investigation. We're going to look at the lab manual in a second. Then there's a student assignment called the mole ratio in 3 different formats. You'll see a Google Slides. So if you use Google Classroom, you can just open this assignment and make a copy for yourself, and you can push it out. You can assign it to students when you make your own copy, because it's going to be view only. What you do is make a copy, put it in your own Google, through your own Google login, and push it out to students. There's also the PDF version, which is fillable. So when you print the PDF, these blue boxes won't show up. They're just there for, if you have it open in a PDF viewer, you can type in your answers, put your name on there, and you can print it. Either print digitally to PDF and turn it in paperless, or you can change to your printer and print a paper copy. So that's an option that's available if you need to go online and have class online because of a shutdown for whatever reason. There's also the editable version, the docx version of the assignment, and this is for every single assignment in the book. And then there's a shortcut to the section review page that has to take a quiz. Here are the answer keys, which I'm not going to open since this is a public webinar. I don't want to just show the answers, but here they are. The answer keys are here in PDF and Word doc version. For the lab investigation, there's a whole lab book that I'm going to show in a second. That'll take you to the answer keys for that. Then there's summary of the lesson. Then there's every single page has unique information where it says present key content. Every page is different. It's a tip that are offered to you by your colleagues, including the authors and the teachers who worked with us, and just people we've heard from, teachers we've heard from, just adding ideas upon ideas upon ideas. On the left side, on the bottom, on every page, something different, some new tip for you. Okay. Also, every time there's a simulation, there's always something on the left side for teachers to know about the simulation. Like, here's what they should get out of this. In case you weren't sure, look for this, XYZ. Okay, so that's nice, nice to have. But you'll notice that on the page itself, the content is pretty much the same as student content. It's really the left margin and the bottom, the yellow areas, that distinguish the teacher content. So we've got a lesson plan, a set of PowerPoint slides, student assignments with answer keys. Now let's look at the lab book, and we'll quickly take a look at how it's different between student and teacher. So it's kind of the same thing. The students see anything that's got a white background, but if it's got a yellow background, it's teacher. So right now I'm in the book, still in chapter 8, because it says text 8.1. If I click the lab book button, I can choose what chapter I want to go to. Let's see what's in stoichiometry chapter. Let me just click that chapter. Okay, I've got something that looks a little bit different here, a little bit different navigation. If I hit the interactors button in the lab book, it brings up the molecular viewer, because this can be really useful anytime you do a lab. Anytime you're working with something you can't see and you want to make it visual, you can always hit that interactors button in the lab book, and it brings up the molecular viewer with the same set of molecules that you see in the textbook. Here on the left side, we've got an investigation presentation, which is fun because it's like if you do labs with students like one slide at a time, this is what this is. It's the same as the lab directions, but it also includes this new slide, the second slide that says think about it, and gets students really thinking minds on before they put their hands on. So a fun question to answer before they do the lab to get them in the right thinking mode. Then again, it's editable, it's PowerPoint and PDF. Then there's the student lab directions in PDF and editable Word document. The directions are the same as the white content on the digital book. So the student lab directions are step by step with safety. That's just the directions. When the part for them to write on, the analysis and the questions, that's a separate document. So here's the directions. You could actually just print out a class set of these, and then each student could get their own answer sheet. Same as before, you could use a Google slide, you could use a PDF, you could edit it from the Word doc version. The teacher version of the lab directions. Now look here on this page, conservation of mats. This yellow section, that's a teacher section. It's lab preparation. This is a section in every single lab. Tells you how to prepare the solutions, things to look out for. If you're doing the lab, like I'm going to demonstrate in a second, determining limiting reactants, it tells you not only how to make the chemicals, but also if you have to put together the equipment in a special way, like this, so that you can get something that looks like this. It tells you how to do that in the lab preparation section in the teacher edition. Also in the teacher edition, besides the answer sheet key, you've got, if it's a SPARKvue lab, you'll see in the materials the little SPARKvue icon with sensor. If it's a sensor-based lab, you can download some sample data. So it says download the file. If I were to download that sample data file, I can see it in SPARKvue. And this is the same data that we use to generate the answer key. Same file. Let me get that open. Oh, I forgot to close my last SPARKvue item. So I'm going to do that again. So I'm going to get so I downloaded it twice now. Open up my SPARKvue file, and there's the data for that lab. We're going to do this lab in a second. So I'm going to hide these. Okay. Then video, if it's a sensor-based lab, here's a video that gives the teacher an overview of what the lab's about. So you can make a quick decision on whether you want to do that lab or not. And finally, every page in in the digital lab book has a reference section with lab equipment and tools, with a printable guide. Let me go back one. Also, a SPARKvue Quick Start Guide, which is a quick shortcut to what's in the sensor software icons. The video that helps you remember how to use all the analysis tools in SPARKvue, and lab safety procedures. So this is only seen on the student side. I'm sorry, on the teacher side, because it's yellow section stuff. So students won't see any of this stuff on the left side here, but they will see all the white stuff here. They won't see lab prep. They will see background safety and procedure. And again, it's going to be the same content that's on the student lab directions. So there. Teacher lab directions are also printable. And again, there's the option to purchase the print versions of the student and teacher lab manuals. Okay, let's look at this lab determining limiting reactants. Let me see if there's anything else I should go over. We talked about the slide set and the answer sheet and the reference materials and the sample data in the video. Now let's look at the lab AD determining limiting reactants. So here's a stoichiometry lab. I'm going to switch to my lab setup here that Heidi has helped me get ready here. Thanks, Heidi. So what we've got here is a container, and this might be for you a 500 milliliter Erlenmeyer flask, or it can be this plastic bottle, or maybe a juice bottle that has the right size hole for a number 6 stopper, because the stopper comes with the sensor. Everything you need comes with a sensor. So what we're going to do is consistently get 40 milliliters of 0.12 molar sodium bicarbonate. You're going to do 5 runs. All 5 runs will have the same volume and concentration of sodium bicarbonate solution, baking soda solution. But we're going to vary the amount of citric acid we add. And when citric acid and sodium bicarbonate react, they produce carbon dioxide, which we can use the pressure sensor to find out the change in pressure because of the production of the carbon dioxide gas. And when we react different amounts of citric acid with the consistent volumes and concentrations of baking soda, we can figure out what is the ideal proportion of these two reactants just based on pressure data and by varying one variable. In this case, the mass, thus moles of citric acid. Here we go. Let's open up SPARKvue, and now I'm going to start SPARKvue fresh. So if you're a first-time user of SPARKvue, this might all be unfamiliar to you. So I'm going to kind of walk through step by step what you would do if you're new. First thing you do, you open up SPARKvue, and because you're using the essential chemistry curriculum, there's a step that says open the experiment file in the lab directions. What that means is go to the bottom left option here, the open PASCO experiment. This is the one you want when it says open the PASCO file. So you open that, and oh my, look, here's a whole folder for essential chemistry in the software already baked in. So when I open that folder, I match the title that the directions say to go to, 8D, determining limiting reactants, and I say okay. And what it does is it gives me a pre-built data display, sometimes having more than one page. On this one, I can tell it has more than one page because there's an arrow pointing to the right, and the directions will say go to the next page in SPARKvue. So this looks like a little bit more complicated setup. That's every single lab, whether it's complicated or not, has a pre-built display page to save students time to just get to that data collection and observation and making connections and thinking about chemistry. So now that I've got the file open, I'm going to turn on the sensor and connect it via Bluetooth right in the app here using the Bluetooth button. And I'm going to wait for the sensor to come up in the menu. I still see my temperature sensor is available to connect, but I don't want that one. I want the pressure sensor, so I tap it. And if I'm not sure if this is my pressure sensor because there's a classroom full of these sensors, I can match the 6-digit ID on the sensor that matches the software. And most likely my sensor will be at the top of the list because the sensors are listed in order of closeness to the Bluetooth signal. So put it on top of your device, it'll probably be on top of the list. So I'm connected now. It's under connected devices. I can say done. I've also got a green flashing light here on my Bluetooth icon, so I know I'm connected. So what I'm going to do, I can look and see I'm at 101.9 kPa. Pressures, we are close to 0 here. and that's a little bit high for being at 0 elevation. So all I have to do is follow the directions, would say hit start, add the stuff, close it, and mix over time. So right now I'm getting the baseline, but as soon as I close the system with the stopper, I can start to see my data growing with time and look at my graph expanding as the data changes, to go by that rule that always make your graph take up the most space that it can, because you never know what points you're going to need to analyze until you see the whole data set, and you want that to be large. So what students are directed to do is to keep swirling at the same rate. And yes, you could use a magnetic stir if you want to throw that in, you totally could. That's why we gave you the editable version of the labs, until the pressure levels off. And it looks like it's starting to slow down, but I can use the graph to decide when to stop. It's still increasing. So on what I did here, while this data is finishing and coming to this reaction slowing down, you can already get the idea across the students that their rate is changing. That's why it's flattening out, because the speed at which the reactants produce CO2 changes, we're running out of reactants. This lab is called limiting reactants. So we're going to have to not only identify the proportion of citric acid to baking soda that's ideal, but also which reactant is limiting and which is excess when it's not the ideal ratio. So again, we're starting to see it's flattening out. And it looks like it's pretty much done. I can also look here at the preview on the bottom left to see that it's really not changing anymore. It's 106.3 kPa, and that's where it's going to stay. I'm going to hit stop. I'm going to open up and do some quick analysis of this data. I want to know the change in pressure. Open the tools. There's a couple different ways I can do this. The first thing I'm going to do is going to add a coordinate tool and drag it to my initial pressure. So it was nice that I got that baseline, because that was the pressure before anything happened. And now I've got that coordinate tool on there. I can show the delta tool, and it gives me a second coordinate point. And then if I drag it to the final data point, it gives me the delta Y, or change in pressure, at 4.4 kPa. If this was decreasing, it would give me a negative. So SPARKvue is intelligent that way. It does things the right way, that final minus initial. So my change in pressure is 4.4 kPa. Now I enter that for my 0.1 value for change in pressure. And you might not be able to see it because it's bright green, but they plotted the point for me, the X and Y data pair of 0.1 gram to 4.4 kPa. Now what happens, I don't have time to do all the runs, but in the next run, they put 0.2, or let's say they got not exactly 0.2, they would have to edit it and put, oh, I got 0.21. That's fine. As long as they're close to 0.2. So they put the exact amount they got, and then they put the pressure they got. And oh my, look, the pressure doubled. So you would see the second run, the pressure would be higher. Third run, oh, we're tripling the mass. Do I triple the pressure? Yes, I do. Oh, awesome. Fourth run, I quadruple the mass. Do I quadruple the pressure? No, I don't. What happens on the fifth run? I multiplied by 5 my initial mass. Do I times 5 my pressure? No, it's flattened out after the third run. That must mean here at the third run, this must be the ideal ratio, because after the third run, everything's flat. So how do I relate that to the reaction? Well, we've got 0.3 grams of citric acid. Let's convert that to moles. Remember, we never changed the moles of baking soda. It was 0.12 molar the whole time. We can convert that to moles, and we can get the proportion, the mole-to-mole ratio, to know the reactant proportion. We also can know from that, what is the limiting reactant? Which one ran out? Well, it depends on the run. Run 1, I must have run out of citric acid, and that must be leftover baking soda. Same for run 2, leftover baking soda. But run 3, it was ideal, so there's no limiting and there's no excess. Run 4 and 5, I was adding more citric acid but not getting anything out of it. So suddenly now citric acid is the excess, while baking soda is limiting. So students can get all of that out of this simple activity, this simple reaction, and collecting pressure data. Let me show you what all of the runs would look like. This is that file that I downloaded earlier, that same experiment. So if I had time, we would have done all 5 runs. So actually what happened, and if this happened during our own data collection, we kept the mistakes there, because mistakes happen, right? That's part of science. So what happened is on our run 5, the stopper actually popped off the bottle, and there's tools in SPARKvue that help you keep track of all the events, qualitative and quantitative, and observational data too. And I wish I had like another 2 hours to go over SPARKvue. It's so fun, but this is just one part of the curriculum. Remember, we got all those other great things. in essential chemistry for you. So that was one of the investigations using the pressure sensor. Now I don't have time to do the pH investigation, so I'm going to skip it when I get to that slide. So let's quick go over the test bank. So you can get to the test bank either from the landing page on education.pasco.com by clicking the test bank button, or you can get it from the teacher homepage. Teacher homepage has this test bank button. Obviously, the student version will not have it. So let me go back to the teacher, go to home. I'm going to go to the test bank through home. Now, if I were to go to the test bank through education.pasco.com, I go to the same place. If I had remembered to log into the test bank before I started this webinar, my test bank would have come up. So I forgot to do that. Oh, you know what? Actually, I think it's in a different browser. That's what happened. Let me quick go to a different browser. Need a second here to log into my teacher book on my other browser. Sorry about that. And we're in business now. Okay, here we go. All right, test bank. So when you log into your test bank and you've got your key entered, it looks like this. You can either pick chemistry or physics. You want chemistry. You can fill out the course name. Sure, I'll call it Chemistry 1A, but I'll also put the chapter. Let's do a chapter 1 test in there so that we can have a test name as well. My name is Puglisi. The course description, let's say it's Chemistry 1A, it's first semester. I can choose different difficulty levels for questions. Level 1 are the easy ones, level 2 are the harder, and 3 are the hardest. We got 3 levels of difficulty here. If I wanted to be really easy tests, I could just select difficulty level of 1. I'm just going to select all 3 though. If I wanted to do all of the questions at once, I could. In fact, that's what I would do if I was a new user here. I just want to see what's available. So I just look at them all and I can delete ones I don't want. I could also add more chapters if I wanted to, but I don't need to do that. Let me just limit it to 5, since that's, I'm going to be able to see that many questions on one page anyway, 5 out of each section from chapter 1. Oh, you know what? I think I'll go to one that's more likely to have some more quantitative. Like, let's go to stoichiometry since that's the chapter we're looking at. How about 5 from each section in stoichiometry? Let's do that. Now I have to change my test name, chapter 8 test, or I could just say stoichiometry test. Okay, so I didn't end up picking anything out of chapter 4. I left it blank. So I should really only get 15 questions, all 3 levels of difficulty. And now I'm ready to continue to step 2. My average difficulty came a little bit harder than average, and that's okay. I can change the difficulty if it came out too hard. I can do that here. If I wanted to add student directions, I could, right here in this box. If I wanted to add more questions, I could do that here from different chapters and sections. So let's say that first question here, it says difficulty is 2. Second question here, difficulty is 3. Well, I'm going to make that easier. And that second question is now change it to a level 1. And now my difficulty went down a little bit. So that's how I can adjust the difficulty of the test easily. I can also move around questions by using the arrows, change places. If I hit swap, it'll give me another question of the same difficulty, but a different question. I can also make the question harder. Level 2 going to level 3 there. So I review my question choices, and then if I'm happy with it, I can either save or build. If I do build, it will save as well. So I'm just going to do build assessments. Let's say I don't want eyes roaming, so I'm going to make 4 versions of this test. I like to give my tests weird names, like a banana, grape, and students fight over what fruit they get. It's so funny. So you can put whatever version you want. You can do A, B, C, D if you want. Lemon, lime, grape, and banana. And we're going to build the assessment. So I've got these 4 versions of this chemistry test for chapter 8. I can edit anything I want. I can edit the name if I didn't like the test name I put on there. Let's look at the preview. And here's a preview of the student view of the test with the question choices. So that's nice. You can see what it looks like. You can print it either, you can print it to your printer or save as a PDF if you want a local copy of it. If you click solution set, it will put the answers up. So I'm going to just show you some screenshots of some answers that I got. So here is what happens. The first thing you see when you put up the answer key, it gives you the ABCD answers. But then that's when looking at answer key. But if you switch to full solutions, It gives you step by step, if you have multi-step answer, it gives you every step of the way of how we got that answer. And if it's a written answer, it gives you the explanation and the concept behind it. And you can print that out from the teacher view. Okay, so that's building tests. Heidi, are there any questions? Great, thanks. Okay, moving along to PASCO Chemistry Academy. So this is included another resource in your ebook. You can get to it right there from education.pasco.com. That would be, oops, I've accidentally circled the test bank button, but you really want the Academy button if you want to go to Academy. And I should say the award-winning PASCO Chemistry Academy, our Academy series for chemistry, biology, and physics got voted for the best video-based learning winner for Best of STEM this year. So yay. So when you go to education.pasco.com, click on Academy, you'll see there's 25 topics, all based on essential chemistry labs. And that will be available to you the whole time of term of your license for the ebook. Let me show you what Academy looks like. So here we are. Oops, that didn't show up on my screen. Let me move over. Here we go. Okay. So Academy, here are all the topics. It's a full year of labs, and again, they're like the ones that are in, they are the ones that are in essential chemistry with a couple different, sometimes different, slightly different answers. So the answer keys are actually always different because we collected new data when we did these Academy videos, and our answer keys go along with the video, the data that's shown in the video. So what is this all about? Well, so this stoichiometry and reactions video, there's a teacher preparation, it explains what the concept covers. 3 different videos of your choice. There's a teacher preparation video. It's for you to watch and see, what did we do? What are the concepts, for you to decide whether or not you want to do this, share this with your students. And what is this? What are you sharing with your students? You're sharing a video, the worksheets they need to get the lab done, and the data set. So you saw me collect data live. You will be given the data set here to give to students so they can do the analysis on their own in case they're out for, they're sick or school shuts down or whatever. You can do labs at a distance. They can watch the video of myself and my colleagues doing and collecting the data, like we're students, we're lab partners, we're getting the data, we're doing safety. You'll see us wearing goggles, we're reading graduated cylinders at eye levels, we're demonstrating all the right things for a chemistry lab. So you get to watch a teacher preparation video, but then there's a student data collection video made for the students. So they watch us collect data. How do we get the SPARKvue file? And here are the files that students will need. Here's the data file, the SPARKvue file that goes along with what they see in the video. If you click the student share, data collection share button, you just copy this URL and give it to them. And if you'd like, you can show the student follow-up video after students have already turned in the work. This kind of goes over the hardest parts or the answers, the struggle points in the lab. So that's not only great when students are absent. What if the teacher's absent and you had a lab plan that day? You can't have a sub do a lab, but you can have a sub do a video lab. So now you can do labs while you have a substitute teacher. And this is also great if you're out of topic subject area, you're brand new to chemistry teaching, it's been a while, you've been in industry, now you're in the classroom. A whole lot of reasons that you could find to use this academy. We're pretty much out of time here. I think I already went through all these things. I think I got to that. Like I said, I didn't think I would get through to the pH sensor, but that's okay. You can find more information about the pH sensor and anything you saw about the essential chemistry curriculum at pasco.com/support. Go there. You can use your phone and get that QR code, and it'll take you to support. And what that does is it'll take you to contact your regional rep, whether you're United States or international or any country in the world. It'll tell you who you can contact. It'll tell you who our selling partner is, and someone from PASCO and someone from our selling partners. So thanks for your time today. I'm going to stop the recording now.